Okay, so I actually wrote this down wrong, so let me fix that real quick. The one I actually wanted was the sum as k goes from 1 to infinity of 3 times negative 1/4 to the k. So what's this look like? I'm just going to write out the first few terms. K equals 1, that would just be negative 1/4 times 3, so negative 3/4. K equals 2, that would be negative 1/4 squared, which would be just 1/16, so this would be plus 3/16. And then k equals 3, that would be negative 1 over 64, so minus 3 over 64. And then finally, k equals 4, that would be 1 over 256, so we're up to 3 over 256, and so on. So I just want to write the first couple terms out, just so we get a little feel for what's happening. Now, since this does not start at 0, that creates a problem for us. Okay? I'm going to show you how we can address that problem. There's two ways to do it. One is to realize that this series, since it's just missing the one term, would be the same as the series as k goes from 0 to infinity of 3 times minus 1/4 to the k. Take off the piece we don't want, which is the 0th term when k is 0. That would be 3 times minus 1/4 to the 0. Okay? All right. Which would be that sum as k goes from 0 to infinity of 3 times minus 1/4 to the k. And then this would just be 3 times 1, be that stuff minus 3. So we just work this out as k goes from 0 to infinity. And then once we get the answer, we subtract 3 from it. So we can just use our formula, a over 1 minus r. So that will be 3 over 1 minus a negative 1/4, and then minus 3 still. And we simplify. That's going to be 3 over 5/4, and it's still minus 3. And then we simplify. 3 divided by 5/4 is the same as 3 times 4/5, which would be 12/5, and then minus 3. All right. And so we get a common denominator, which would be 5. 12/5 minus 15/5. So the overall thing is going to converge to negative 3/5. Okay, so that was just stripping off. And when you're just stripping off like a single value, or even if it was like going from 2 to infinity, that wouldn't be so bad. But if this was going from like 10 to infinity, then this approach really would leave a lot to be desired. Okay? So I'm going to show you an alternative way. This is actually the way I prefer to deal with something like this. And the idea is I'm going to rewrite it as a sum as k goes from 0 to infinity. So I can just jump into that formula without having the extra terms to chop off. So the alternative way is to first just start expanding our sum and seeing what it looks like. K equals 1 to infinity of 3 minus 1/4 to the k. So what would that look like? Well, the first term would be 3 times minus 1/4 to the first, plus 3 times minus 1/4 squared, plus 3 times minus 1/4 cubed, and so on. And so here's what I do. I notice that every term in this thing has a common factor, and I can pull that common factor out. And the common factor is 3 times negative 1/4, which will eventually be a negative 3/4. Because when I pull that out, my first term is now a 1. And now when I pull it out here, I'll have a negative 1/4 to the first plus negative 1/4 to the second, and so on forever. Okay. So on and so on forever. So I can actually write this now as the sum as k goes from 0 to infinity of negative 3/4 times negative 1/4 to the k, because my sum's starting with 1 now. There, my sum is starting with a 1 there. Or you could pull the negative 3/4 outside of the sum, the series. We could do it either way. It comes up to you. It's not going to change anything whether you write it inside as I did here, or you write it on the outside. And so now we have our series expressed as a geometric series starting at 0. So we can just directly use our formula with what we have. And so the formula here would be negative, or a, negative 3/4 divided by 1 minus r. 1 minus the negative 1/4. Right? And simplify. Right? That would be negative 3/4 on top divided by 5/4. But dividing by 5/4 is the same as multiplying by 4/5. The 4's cancel out, and we get negative 3/5, which was the exact same answer we got when we did it the other way. So this is how I prefer to deal with the geometric series that doesn't start at 1, or doesn't start at 0, is write it out, and being a geometric series, it's going to have a common factor. Factor out that first piece, whatever it is, to turn the rest of the stuff into a geometric series that starts at 0. And so that's how I like to approach these problems. So we'll see some more examples as we continue on.